When sizing power quotes for motor-operated equipment, calculating voltage drop is essential, especially when considering the motor's starting characteristics. While using a 5% voltage drop rule based on the full load amps of law may suffice for steady-state operation, it might not adequately address the voltage drop during motor startup. During startup, a motor draws a significantly high current, known as the locked rotor amps, or LRA, which can be several times the FLA. This high inrush current can cause a substantial voltage drop in the supply cables. If the voltage drops too much, it can negatively affect the motor's ability to start successfully. Calculating voltage drop using locked rotor amps ensures that the selected supply cables are capable of handling this peak current demand during startup. Furthermore, it helps to maintain the voltage drop within acceptable limits to prevent voltage sags that could hinder the motor's acceleration. The allowable voltage drop during motor starting is not fixed and depends on the specific type of motor and its particular starting characteristics. As a general guideline, a voltage drop of 15 to 20% of the rated voltage is considered acceptable for most motors. However, it is crucial to recognize that some motors may have more stringent starting requirements that necessitate a lower voltage drop to ensure reliable starting. Voltage drop is directly related to the current flowing through the cable and the resistance of that cable. Since locked rotor amps are much higher than the full load amps, using the locked rotor amps value in your voltage drop calculation will invariably result in a higher calculated voltage drop in the supply cables. Therefore, even if your initial calculation based on a 5% voltage drop using full load amps seems sufficient for continuous operation, it is advisable to calculate the voltage drop using locked rotor amps as well. This will help to verify that the motor can start reliably without experiencing excessive voltage drop, which could damage the motor or prevent it from starting altogether. Consider NEC tables like Table 430.52 for motor protection as well as the tables in Chapter 9 for conductive properties.